Alright, Algebra 2, here we go. I'm not going to lie to you. Systems with three variables can be very long. Not so much difficult, but definitely long. It could take you a whole page or a page and a half to do one problem. So let's just get that right out at the beginning here. Our essential question is, how is this solving three variables similar to solving two equations and two unknowns? Okay. Well, I started out here, I gave you a couple of steps to kind of lead you through how to solve the problem. It's a general way of going about solving the problem. There's more than one way to do it. I'm going to try to show you one way so we can just work it that way. There's always a shortcut here or there, but I'm telling you right now, if you try to use some of those, you're not going to know what to do on the next step. So we'll just try to follow one method here. And what we're going to try to do is, you're going to get three equations, and I'll show you an example here. We want to arrange each row of equations such that we have an x, a single 1x in the first row, if that's possible. Then we're going to do the elimination method, just like we did up here with two equations. And we're going to try to use that first row with the second row and try to multiply so that we can eliminate an x and create a new second equation. And then we're going to use the first and the third row to eliminate the x in the third row in order to come up with a new third equation. Then you're going to take that new second and third equation and try to eliminate the y in the third equation. That'll put you in triangular form, then we can solve for y and x. What does all that mean? Here we go. Let's take a look. Okay, we start off with a problem like this. Three unknowns, x, y, and z. X plus 3y minus z equals 11. 2x minus y plus z equals 4. And 4x plus y minus z equals 14. Double check your problem when you write it down. Because if you put a wrong sign in here or mix up, take a 2 out of the second equation, it should go in the third equation, you're going to be all screwed up. So double check your equations once you write them down. Okay? We want to solve for x, y, z. This is an ordered triple, just like we have ordered pairs when we graph on the x, y. Now we're kind of making it three-dimensional, so it's x, y, z. Okay? You get length and width and depth now. So, how do we go about doing this? Well, I'm going to start out, like I said, I'm going to take the first two equations and I'm going to look at these x's right here and I want to be able to add them up so we can eliminate an x. So, for us, that's going to tell me right here, multiply this equation here by -2. Okay? So I'm going to take -2 times x, I'm going to get a -2x. -2 times the 3, that's going to give me a -6y. -2 times the negative z, that's going to give me a plus 2z. And -2 times 11 is -22. Okay? Multiply all the way across. Bring your second equation over, you don't need to do anything to it. This should look similar to what we've been doing here in the last section. Now we add them up, elimination method, boom, our x's are gone. I get -7y plus 3z equals -18. Be careful with your signs, check your arithmetic here. This is what we're going to call our new second equation. Okay? Now let's take the first and the third, these two right here. Okay? Now I'm going to multiply this first equation by, instead of -2, I'm going to multiply it by -4. Okay? -4 times x is -4x. -4 times the 3, that's -12y. -4 times a -1, that's going to be a plus 4z equals -44. Okay? Be careful of your arithmetic. If I get through this and don't make an error, that's going to be a first. Just got to be careful. Take your time. Add them together. Elimination method. Boom. You can see your x's are gone. -12 plus 1 is -11y. 4 minus 1, that's plus 3z's, equals -30. That's going to be our new third equation. Okay? So now I go back up here. I'm going to rewrite now. I'm trying to get to this triangular form, the thing I talked about in the last step here of those notes. So I've got x plus 3y minus z equals 11. That's not going to change for us throughout the problem. I'm going to take my new second, minus 7y plus 3z equals negative 18. Take my new third, negative 11y plus 3z equals negative 30. Okay? Double check here. Looks like I'm good. Okay, so here's our, you can kind of see we're starting to get this triangular deal right here. That's what it's going to look like. And I'll point that out to you when we get there. Right now I want to get rid of this y right here. Okay? Using the elimination method, I want to get those two to be the same. Right now they're the same sign, so one of these is going to get multiplied by a negative, the other by a positive. And I'll just say 11 and negative 7. Okay? Because I know that'll give me a negative 77 here when I bring this over here. Y, 11, that's going to be a plus 33z. And 11 times 180, that's going to be a negative 198. Okay? Negative 7 times a negative, that's going to give me a positive 77y. Minus 21z. And that's going to give me a positive 210. Add them up, boom, the y's are gone. I get 12z equal to 12. Divide out the 12. Z is equal to 1. Okay? Everybody got that? So we took the first two equations. I want to get rid of this right here. So I multiplied by negative 2 here. So they cancel. Make sure you multiply all the way across. Got a new second. Then I took the first and the third. I multiplied the first one by negative 4 all the way across. Combine, add it down just like the elimination method we've been doing. X's cancel. I get this. I get a new third. Checking your arithmetic as you go. I rewrote the new second and third right here. Then I want to get rid of this here. So I used 77y. Multiplied accordingly so that my signs would be different. Elimination method. I'm actually able to solve for z. So what do I have now? Let's look at our triangular form because now you're going to see it. We've got our x plus 3y minus z equals 11. We've got our second equation, that new second equation. I'm not going to change it. And then I've got z equal to 1. See the triangular form right here? That's what we mean. That's triangular form. Okay? I know what my z is here. So what I'm going to do is I'm going to plug this into this equation. Okay? And that right there is going to give me negative 7y. 3 times 1 equals negative 18. I'm going to subtract 3. Negative 7y equals negative 21. Divide out the negative, I get y is 3. Okay? I'm going to use those two, this one and this one. Now I'm going to put it into here. So I'm going to get x plus 3 times 3, that's my y, minus my z, which is 1, and that's supposed to equal 11. X, 9 minus 1 is 8. Subtract the 8 over. X is equal to 3. 3, 3, 1. There's my answer. Okay, is it long? Yeah. Let me stop the whining right now. That's just the way it's going to be. Okay? We got rid of the x's, took our new second and third equation, got rid of the y, so we can come up with triangular form. And then you just plug that back into here, solve for y. Take those two answers, plug them in here, and solve for x, and you got it. Okay, tomorrow when you come into class, we'll look at some more of these problems. I'm sure it's a little confusing at first, it usually is, but once you kind of get the hang of it and you see how it relates to the elimination method we just did, it gets a little easier, but it doesn't make it any shorter, it's still long. Okay, we'll see you in here tomorrow, and we'll get started on this. Have a good one, bye.